Alright, all you cool cats and kittens, and for anybody that offended, I am truly sorry. Let's see what we got here. Alright, so this is Unit 6-7 Notes. It's not written anywhere, so maybe I should write it. Unit 6-7 Review Notes. This is going to be a long video, so I'm going to be brief in lots of places. Definition of the definite integral, that's area under the curve. Now, Riemann sum, they have problems that are Riemann sums, but it's just how thin the sections are. I'll show you what I mean by that in the next part. There's often a Riemann sums question on the multiple choice. You don't have to worry about this year, but I'd never worry about it. It's incredibly complicated. It's not even complicated. It's hard to keep straight. It's one more major thing to memorize, and it shows up every second or third year, so I just move on. LRAM, left, I forget what LRAM stands for. Left, middle, and right. Adjusted, yeah, I can't remember, area. So what does LRAM mean, which is what I really care about, is they say, hey, find the area under this curve, and they give you 4 points. LRAM means start on the left side, and it goes to 0 and make a rectangle. Then the left side of the 1, 2, make a rectangle. Left side of the 2, 3, left side of the 3, 4. And then add all those areas up, and that gives you an approximation for the area. Now, Riemann sum means as those divisions that are now 1, the delta x's, as we take the limit, as delta x goes to 0, we get area. So I'm going to write colors on top because this will take forever to do twice. Let's go with green, and MRAM would be go up to the middle and go both ways. See, an MRAM is your best approximation, but it doesn't really matter. They love to ask the question, an LRAM is going to be an underestimate because it's an increasing function, things like that. So be prepared. Let's see what else we got here. Blue. So that's a right ram. Go to R and come across to the right side and come across. So on and so on. So that's LRAM, MRAM, RRAM. Most people remember that. Notice an RRAM would be an overestimation because it's an increasing function, that sort of thing. What's NINT mean? Well, that's on your calculator. It's math 9. And you got to put your areas in. And if you're calculating area going to the right from 0 to, say, pi here, it's going to be positive. But if you're calculating it going to the left from, say, pi to 0, it's going to be negative. So that's what this says right here. If you flip your limits on your integral sign, you will get negative of what you would have gotten otherwise. It's a handy little skill to use. Be aware of it. And average value of a function, you take the integral from a to b and you subtract by b minus, divide by b minus a. So for example, I've written up a problem here, or I've stolen a problem here. Average value of 9. So 9 equals 1 over k minus 0. The integral of x to the third from 0 to k with respect to x. 9 equals 1 over k. So this is going to be x to the fourth over 4 from 0 to k. 9 equals k to the fourth over k times 4. The 0 is going to drop out. It's basically minus 0, but I'm not going to bother. So this becomes 3. That goes times 4 times 4. We get 36 equals k to the third. K is the third root of 36. Yeah, I think that's accurate. I make mistakes, so watch out. Make sure I didn't screw anything up in there. x to the third, x to the fourth over 4. Yeah, that looks good. So how do we do a derivative of an integral? Well, they cancel out. So if we had an integral from 0 to x of sine of x squared, which we don't have the techniques to do right now, we said, hey, take the derivative of that respect to x, you would just get sine of x squared. Now, if the x squared was here, we have to chain rule it. So you would get x squared in for x, you get x to the fourth, and then you have to multiply the whole thing times 2x, because that's the derivative of x squared. That's confusing stuff. Go back through your notes, make sure you know what that is. You will see that on multiple choice almost every test, AP test. So trapezoidal rule. So what's a better way to approximate this if we have to go 1, 2, 3, 4? Well, we can always just make a trapezoid. So go up and over. And these are our bases. And this is our height. And area of a trapezoid is 1/2 the height times base 1 plus base 2. So this is not meant to go through that in great detail. You need to remember how to do that. But that's your basic formula. There's a whole bunch of shortcuts for that, but I would avoid them if at all possible. Integration by substitution. You look at a problem and you say, hey, I see the derivative of x squared in the problem, so I can just do that. So I go u equals x squared, du equals 2x dx, and then I solve for dx because I'm going to substitute for dx. I have to keep going. If we do u substitution, we got to take care of the limits. So u of 1 means plug 1 in here, still 1, and u of -1 is also 1. So we're going to go from 1 to 1 with all this. The answer is going to be 0, but we'll check it and make sure that's the case. So integral from 1 to 1. Interesting. X just sticks along, e to the u. Alright, and dx is now du over 2x. Cancel, cancel. I pull the 1/2 out front. Integral from 1 to 1 of e to the u is just 1/2 e to the u from 1 to 1, which is 0. Neat problem, but it does show how to do substitution. And then integration by parts. So here's an integration by parts. U equals x, du equals sine of 2x dx. Derivative, du equals dx. Integral, u equals negative cosine of 2x over 2. Don't know what I just did? Well, take the derivative of negative cosine 2x over 2 and you should get sine of 2x. So the answer now becomes this. Negative x cosine of 2x over 2 minus the integral of this, which is negative negative, so I'm just going to pull that out front. There's a 2, I'm going to pull that out front, and cosine of 2x and dx. Oops, ran off screen there. Dx, which is negative x cosine of 2x over 2 plus integral of cosine of 2x is sine of 2x over 2, 1/4 sine of 2x plus c. Again, I'm going very quickly. You're going to have to check that out. How do we handle this? Well, this is one of my favorite. It's separation of variables. It's really not that hard, but people freak out. You've got dy dx equals y secant squared x. Get all the x's and dx's on one side, get all the y's and dy's on the other, and we get dy over y equals secant squared x dx. Integrate ln of y equals tangent of x plus c. I think that's right. E both sides, and we get y, and we're going to just ignore the absolute value because I'm lazy. E to the tangent of x plus c, which is the same as e to the c times e to the tangent of x, which is some variable, k, I don't know, call it whatever you want, tangent of x. So we could go and figure that out if we had some initial conditions. Oh, we do have initial conditions. I'm not going to do it just in the interest of time, but plug them in and see what you get. I think you get k is going to be 5. No. 1 over e, I think. Check it out. That's a problem that you have, and you should try to make sure you know how to do it. Alright, so one more. So here we go. X, I'm not doing any calculus, I'm doing algebra. A over x plus 3 plus b over x plus 2 multiply through by x squared plus 5x plus 6, and I get x. I just realized I'm going to run out of room. Equals a times x plus 2 plus b times x plus 3. X equals negative 2. B equals negative 2. X equals negative 3. A equals 3. Negative 2, negative 2, 1, negative 3, 3. Alright, cool. So now we can do the integral of 3 over x plus 3 dx plus the integral of negative 2 over x plus 2, which I believe gives you 3 ln of x plus 3 minus 2 ln of x plus 2, and then we can simplify using the laws of logarithms. So that's a lot. I really cannot overstate how much you need to be practicing problems. You have a bunch of Unit 6, 7 review problems to work off of. Good luck.